Hi, in this video, we're going to take a look at the role of the IPv4 subnet mask and packet forwarding determination. So this is some key concepts that is not always well understood by those beginning networking, so I want to make sure we understand this. So remember that every device has an IPv4 device has an IPv4 address and a subnet mask, right? And it needs that information to know what network it belongs to because it lives in a bubble. It doesn't know the world outside of itself. It also has a default gateway address. So if it needs to reach devices outside of its own network, it knows who to forward those packets to. Okay, so remember, we can use things like the ipconfig command in Windows to examine our IPv4 address and our subnet mask, which tells us the network portion and the host portion. All right. So first of all, IPv4 devices can only communicate directly with other devices on their same subnet. So if computer A here has a packet with a destination address for computer B at 192.168.10.11, it has to figure out, are you on my network? Okay, because remember, I've got to encapsulate this in let's say an Ethernet frame, and that destination MAC address, I've either got to send it directly to you if you're on my network, or I have to send it to the default gateway. So how does A know if B is on its same network? Okay, well, first of all, A knows what network it belongs to because it uses its IPv4 address and subnet mask and comes up and says, oh, I belong to the 192.168.10.0 network /24 with my mask. Okay, so, but it doesn't know the subnet mask of the destination. That's key. But it does know this. It says, you know what? If you and I are on the same IPv4 network, then we have the same mask. So I'm going to do this. Okay, I'm going to take your IP address, the destination IPv4 address, and use my mask, the mask of A, 255.255.255.0, do the AND operation on it, and compare that to my network address. Okay. In this case, both network addresses are the same, that of A, and looks like B is on our network. So A can now encapsulate this IPv4 packet in an Ethernet frame with the destination MAC address of B. Remember, if it doesn't know the destination MAC address, what will it do? You're right. Well, first of all, it checks its ARP cache to see if it has the MAC address associated with this destination IP address, IPv4 address. If it does not, it sends out an ARP request, gets an ARP reply from B, has its MAC address, and goes ahead and sends it out. All right, let's take a look at another example. In this case, we've changed the IPv4 address of C, the destination IP address. Okay. So again, A knows what network it belongs to. It has its IPv4 address. Its subnet mask does a bitwise AND operation to determine that it's on the 192.168.10.0 network. Okay, oh, I've given you a little hint there of what's going to happen. But it doesn't know the mask of C, but it says, you know what, if you're on my network, we have the same mask. So I'm going to take the destination IPv4 address, that of C, use my mask, that of A, and ooh, it looks like we have a different result in the bitwise AND operation. It shows a different network address. Now, it doesn't really know that this 192.168.20.0 address is C's network address because it doesn't know the mask of C. But it does know this. You're not on my network. A says, we're not on the same network. So in this case, what A would have to do is it says, I can't reach you directly. You know what? If we don't have a router there, we're in trouble. So we need to get a router involved. Okay. So A can reach B directly if they're on the same network. But if they're on different networks, they cannot reach each other directly. This is where we involve the router, the default gateway. Okay, the packet will be sent to the destination MAC address associated with A's default gateway, the router's interface on that network. All right. Hope this helps explain a little bit about why it's so important we need that IPv4 address along with the subnet mask to determine what network it's on, and how it's used to determine whether the destination IPv4 address is on the same network as itself, whether it can reach it directly, or whether it has to forward those packets onto the router for the default gateway and let it forward it. Okay. By the way, in IPv6, this all works differently. Okay, it uses something called the on-link flag and something called a router advertisement message. Talk about that in IPv6.